Warm welcome you all to channel Meet MIT, that is Math is Tricky. In this video, I'm going to share some tips and tricks about the application of derivatives. We know mathematics is very useful. In mathematics also, derivative is very useful. But what are the application of derivatives? So let's see here, to understand this concept, let's start with rims. See here, rims. RIMS. So, what is the meaning of R? R stands for rate measurement. That means at what rate an aeroplane is flying, at what rate the distance between any 2 points is increasing, at what rate price is increasing, at what rate the gold price is increasing. So many things, anything related about rate. So, at what rate acceleration is being increased, at what rate a force is being increased. So anything related to rate will be measured, and its application, its problem will be solved with the help of derivative. This is the first application, and I stands for increasing or decreasing functions. Whether a given function is increasing or decreasing at a point, maybe in the interval also. Okay, so we can easily determine whether the given function is increasing or decreasing at given points or given interval with the help of derivative. This is the second application. Third one is maximization or minimization. We may be interested in maximization of a function. We may be interested in maximization of profit. We may be interested in minimization of our cost. So this type of function, to whether we have to find a maximum or minimum value of a function, this all can be discussed with the help of mathematics, with the help of derivative. The last one, yes, stands for slope. Derivative gives the slope of any tangent to a curve at a point. Not only it gives the slope of straight lines, it gives tangent to any type of curve at a given point. So in easy way we can remember the applications of derivative if we remember this word RIMS. First steps to find increasing or decreasing function. Okay, so that it will be easy for you to solve the problem. First one, step 1, find dy by dx or first derivative. Okay, that is first derivative. Second step will be always step 2, examine the sign of dy by dx at the given point or in the given interval. Okay, after finding dy by dx, we need to check the sign of dy by dx at the given point or in the given interval. The step 3 is simply make a conclusion. If dy by dx is positive, it will be increasing, and if dy by dx is negative, the function will be decreasing. This is what I'm going to follow. These are the steps. If we complete these 3 steps, I'm sure you'll be able to solve any problems regarding increasing or decreasing function. Okay, you can easily determine whether the given function is either increasing or decreasing at the given point or in the given interval. I've taken some problems. I'll be solving for you. Please be with me. Please be with me and boost up your mathematics. You'll be benefited by watching this video. So watch till end. Your concept will be clear and you will be solving many more problems regarding increasing and decreasing of a function. Okay, these are the steps I'm going to follow. Let me repeat once again. Find dy by dx, that's the first step. Second step is examine the sign of dy by dx. That means check the sign of dy by dx at the given point. Third step will be if dy by dx is positive at the given point, the function will be increasing. Remembering positive means increasing. It is easy to remember. And if dy by dx is negative, the function will be decreasing. So decreasing means here negative. Okay. Now let me solve the problems for you. These are the three steps. You can remember these three steps as mantra, or these are the tricks to solve the problem. Okay, the for first problem, let me check whether the function is increasing or decreasing. Here we are given first function fx. We are solving first one. Fx is given 15x square minus 14x plus 1. So let's find f dash x. So simply it will be 15. The derivative of x square is 2x. Derivative of x is 1. Constant is 0. So it is simply 30x minus 14. Now, when x equals 2 by 5, let's take first derivative. So, what is the value of first derivative? 30 into 2 by 5 minus 14. It gives here 6 times. That means 12 minus 14, and it gives here minus 2. That is, we can write here f dash x at 2 by 5 is negative, so we can write here so fx is decreasing at x equals 2 by 5. That's our answer. Now we have checked at the point 2 by 5. This function is decreasing at 2 by 5. So now let's check whether it is increasing or decreasing at the given point, that is the next point, at x equals 5 by 2. Let's check the value of first derivative. It becomes here 30 into 5 by 2 minus 14. It is here 15 times 75 minus 14. It gives here 61, which is greater than 0. That is, the function is positive here, so fx is increasing at point x by 2, at the point 5 by 2. This is our answer. Now we have the answer for first question. Let me solve another question. So please practice and practice. There is no other way. If you practice a number of times, you will be able to solve any problems of mathematics. Question number 2. Next question we are given here. Let's check whether the function is increasing or decreasing again. So here we are given fx equals 2x cube minus 24x plus 15. So as before, our first step is same. Let's find first derivative. So derivative of this is here simply 6x square minus 24, because derivative of x is 1 and derivative of constant is 0. So at the given point at x equals 3, let's find the value of first derivative. So it is simply 6 into 3 square minus 24 is here 9 times 6, 54 minus 24, and it is here simply 30, which is greater than 0. That means first derivative is positive, so fx is increasing at x equals 3. This is our conclusion. Remember, I'm following 3 steps. In first step, I'm finding derivative of the given function. Second step, at the given point, I'm checking the sign of the first derivative. At last, I'm making the conclusion. If first derivative is 0, we'll get stationary points. But if first derivative is positive, the function will be increasing. If first derivative is negative, the function will be decreasing. So we have done for first point. Let's check at x equals 3 by 2. First derivatives becomes, simply put here value of x. So 3 by 2 whole square minus 24. By simplification we'll get here it is 9 by 4 minus 24. So we can cancel this 2 3s and 2 2s. So it is here simply 9 3s are 27 minus 48 by 2. So simply we'll be getting here 1 and 21 by 2. It is negative here, less than 0. So we can see here, so we can write here our first derivative is negative, so conclusion will be fx is decreasing at which point? At 3 by 2. X equals 3 by 2. This is our answer. This is the solution for second question. I'm going to solve next question for you, and the question is here for third question. Already we have solved first 2 questions. Now question number 3 for third question. We are given here fx as 2x square minus 4x plus 3. So as before, let's find first derivative, and it is simply here 4x minus 4. Now instead of giving point, we are given here interval. It is half open, half closed. So let's take here for interval, we have to check here for 1 comma 4, that is half closed, half open. In this, for this, take any point in between this. So obviously more than 1, less than 4. So if we take here 2, so we can see here at x equals 2, f dash x becomes simply here 4 into 2 minus 4. 8 minus 4 is 4 greater than 0. That means we can write here for x belongs to this interval, given interval, f dash x is greater than 0. Okay, so we can do this in the, so we can write here, so fx is increasing in the given interval. Hope you are understanding this. If you have any confusion, you can write it in comment also. Please you share your feelings, whether you are understanding or not, whether you are getting benefited from this video or not. If you have any confusion, if any suggestion, please feel good to write in comment box. Okay, let me move for another question. Question number 4. We are given here another function fx equals minus x cube plus 6x square minus 13x plus 20. And now we are going to check whether it is increasing or decreasing for all the real values of x. So as before, we'll find first derivative, and we can see here minus 3x square plus 12x minus 13. So what we can do here, we can take minus 3 as common, so that will be getting here x square minus 4x plus 13 by 3. And if we simplify further, then we'll be getting here x square minus 2 into 2x plus 4 minus 4 plus 13 by 3. So by simplification we'll be getting here this as x minus 2 whole square, and then plus it is here 13 by 3 minus 4, it is simply 1 by 3. So this is our first derivative. Now we are going to check whether this function is increasing or decreasing for all real values of x. So we can easily see that since x minus 2 is always whole square is always greater or equals to 0, and x minus 2 whole square plus 1 by 3 is always positive, f dash x will be simply less than 0, because this whole is, remember this whole is positive. Okay, positive times negative is negative, so first derivative is negative. So we can say that the given function, so we can say that so fx is decreasing for all x belongs to, or for all real values of x, the function will be decreasing. Okay, so this is of another type. Let me solve one more problem. Question number 5. Solve this also. Number 5, here we are given fx equals 4x minus 9 by x plus 6. Now again we have to check this function, whether it is increasing or decreasing for all the real values of x except x equals 0. So as before, remember I'm following the 3 steps. Once again I'm repeating, I'm just following 3 steps. The first step is I'm finding dy by dx in first step. Second step, I'm checking the sign of dy by dx at the given point or in the given interval. And in third step, I'm making the conclusion with the help of the result. If dy by dx is positive, the function will be increasing. If dy by dx is negative, the function will be decreasing. Okay, so by the same steps, we are going to solve this question, and the solution is here. So derivative will be 4 minus 9. So let me solve it through process. So first derivative is simply here 4 dx by dx minus 9 dx power minus 1 by dx. So direct also we can write d6 by dx. So simply we'll be getting here 4 into 1, and minus minus it will be plus, simply x square plus 0. So we can write here 4 plus 9 by x square. So we can easily, this is our first derivative. Now this is going to be as a square of since x square is always greater or equals to 0. This is going to be always positive. Okay, so this is always positive. Now this is always positive, so we can write here, so this is positive, always greater or equals to 0 means f dash x will be always greater than 0 for all x belongs to R except x equals 0, except x equals, because the function will not be defined if we put here x equals 0. So it will be, so it is increasing for all x belongs to R except that's writing here x is equals to 0. So the function will be always increasing. In what interval and the previous function we have already discussed. The function was 1 by 1 for 6. Hope you enjoyed this video, and if you like this video, 3x square minus 6x plus 5. So how to find, I'm going to discuss uh, and solve this problem. In what interval this function is going to be increasing or decreasing. So for that also we'll follow the same process. Let's find the first derivative. It is 6x minus 6, and if we take here common, 6 is common, x minus 1. Now let's check here for what value this function, this f dash x or the first derivative is being 0. So for x equals 1, so find here 1. So these are two intervals, so we can write here minus infinity to 1 and 1 to infinity. For these two we'll be checking here. So if x belongs to minus infinity to 1, take any value which is less than 1. So if you take here minus 1, so minus 1 minus 1 minus 2, for that y dash will be less than 0. So it is decreasing in the interval minus infinity to 1. First part is this. Now let's check for this second interval. So if x belongs to 1 to infinity, so y dash will be simply, how to know that one, take any value just greater than 1. So 2, if you take here x equals 2, you'll be getting here 2 minus 1 positive. That means y dash is positive. So we can write here it is increasing in the interval 1 to infinity. That's your answer. Okay, let me solve another question for you. Hope you are understanding this. So, and you can also solve in very fast way, in very less time, if you practice. There is no other shortcut. You must practice a number of times. Okay, then you can do easily. Just I'm here sharing some tips and tricks, some ideas to solve the problems in a faster way. Okay, so let here again y equals x power 4 minus 1 by 3 x square. So as before, let's find first derivative. It is 4x cube minus 1 by 3, and it is simply here 2x. So if we simplify this, y dash equals 4x minus, it is here 2x by 3. So we can take here common. So if we take here x common, so we'll be getting here x common. So we'll get 2 also common, 2x common. So that will be getting here x square minus 1 by 2x square minus 1 by 3. So sorry, this in this question number 7, it should be here x cube. So first one x cube. Okay, question number 7. Let's solve question number 7. So let here y equals x power 4 minus 1 by 3 x cube. So that will be getting here y dash as before. Let's find y dash. So it will be here 4x cube minus 1 by 3 and 3x square. Y dash becomes 4x cube minus 3x square. So if we take here x square common, so we'll be getting here x minus 1. Okay, so that is 4x minus 1. And then for what value it is being positive or negative, we have to check that. So before that, it will be 0 if you put here two values. See here, for 1 by 4 and for 0 also it is giving answer 0. So now we can have different intervals, the second interval, third interval, y dash. So if we take here x less than 0, so we can take here any number less than 0, so it will be simply here, if you take here minus 1 x equal, let's take here less than 0 is minus 1, so y dash becomes how much? Minus 1 square is simply minus 1 square, and then minus 4 minus 1, it gives here minus 5, which is less than 0. So that means first derivative will be less than this. All can be done in tough also. We can do this in our mind if possible. So we can write here it is decreasing in the interval minus infinity to 0. Okay, now so the second interval is again, if we see here, so for this interval 0 to 4, x belongs to 0 to 1 by 4, we can see here y dash equals, y dash will be simply here, let's take here 0 to 4 means here in between 0 and 1 by 4, less than 1 by 4. 1 by 4 is not included here, so it will be I think 0 and 0.25. okay, also we can take here 0.2. so what we are getting here, this will be, if we take here let me show here, let's take here x equals 0.20, so it is here in between this. So what we get here, y dash will be simply 0.2 whole square, this is positive, and it will be here, or 0.8 minus 1, again we are getting whatever here negative, okay, because this is negative. So what do we get here? So it is again negative, so it is decreasing uh, in the interval 0 1 by 4. okay, so we can see here, if we combine these two, this and this, we can write here it is in decreasing in minus infinity to 1 by 4 also. okay, so this is decreasing in this interval. okay, now for the last interval, if it is more than 1 by 4, what is happening? Let's check there. okay, so when x belongs to the next interval here, 1 by 4 to infinity, we can check here infinity, so it belongs to 1 by 4 to infinity. If we take here more than 1 by 4, so 1, so 4 minus 1 is going to be, y dash is positive, so it is increasing in the interval 1 by 4 to infinity. okay, this is how we can write. We can find the intervals in which the function is increasing or decreasing. okay, hope you are getting. Let me solve other problems and explain it for you. Question number 8, if you talk about this, question number 8, again we are going to find the interval in which it is increasing or decreasing. Let's find here, consider the function as 5x cube minus 135x 35x plus 22. So what will be there? Y dash, if you find y dash, it will be 15x square minus 135. So y dash will be, take here x, 15x common, x square minus 9. So we can write here y dash 15 times, let's factorize this, x minus 3 and x plus 3. It means here for two values it is going to be 0, it is here minus 3, as before. We'll make here three intervals, this one, second one and third one. okay, so we can write here when x is less than minus 3, y dash we can check here, y dash becomes minus 3 means we can take here uh, x equals minus 4. So this is negative, this is also negative, both negative, so this is going to be negative and negative, so it will be, both will be here. This is negative, you can check here, y dash equals 15 times minus 7 and then minus 1, so it is positive. So increasing in interval minus infinity to minus 3, first one. So let's check here for second one, when x belongs to the interval minus 3 and 3, we can check here y dash. Let's put here 0 so that it will be simply here negative and this positive, so negative. This will be again negative means less than 0, so it is decreasing in the interval minus 3 to 3. Okay, so for next one, let me show you whether it is increasing or decreasing for this one. So it was here 15, x minus 3, x plus 3. So we can check here for x belongs to 3 to infinity, we can easily check. Take here for this positive, so it is here positive, so it is increasing in the interval 3 to infinity. That's our answer. Okay, let me submit another question and explain it for you. Hope you're enjoying this video, and please if you like this video, don't forget to subscribe my channel and share among your friends. Let's move to question number 9. Let here y equals 6 plus 12x plus 3x square minus 2x cube. As before, let's find your first derivative, so simply it will be here 12 plus 6x minus 6x square. So let's take here common, 6 is common, so we can take 6 as common, so it will be 2 plus x minus x square. Let's simplify this further. 6, we can factorize this, 2 plus 2x minus x square. If you simplify, we'll be getting here 6, and then 2 is common, 1 plus x. If we take here minus common, x common, so it is here 1 plus x. So we can write here y dash equals 6 times 1 plus x times 2 minus x. Okay, so this is as before. We'll check whether at what point it is in first giving 0. At what point the first derivative will be 0, so it is here minus 1 and 2. So as before, when x is less than minus 1, so we can take here minus 2. So if we take here x equals minus 2, we can see here y dash becomes 6 into minus 2 plus 1 minus 1, and then minus 2, and because of this minus to be plus, so it is here 2 plus 2, 4. It is simply here less than 0, negative. So y dash is less than 0, so it is increasing in the interval minus infinity to minus 1. Okay, so for next interval, if we check here, this interval when x belongs to minus 1 and 2, let's take here 0, so this is going to be positive, this is going to be also positive. F y dash is positive, so it is simply between these two, it is simply 0, so 0 gives a positive, so it is increasing in the interval minus 1 and 2. So I can check here for the last one, 2 to infinity. Okay, so what we are getting, so let's check here for if x belongs to 2 to infinity. If we check here, that means more than 2. If we take here more than 2, this is going to be negative and this is positive. So y dash is positive, this is negative, this is positive. So less than 0, it is decreasing. So in which interval? 2 to infinity. That's your answer. Okay. This is just it is taking time because I'm explaining, but if you try by yourself and then follow the steps that I've given, I'm sure you can easily solve the problem within just few minutes. It will not take more than 2 minutes. Okay, so question number 10, let here y equals x cube minus 12x. So as before, let's find first derivative 3x square minus 12. We can take here 3 as common, so x square minus 4. Let's simplify this as 3 times x minus 2, x plus 2. I'm just factorizing this using a square minus b square formula. So as before, this is giving here minus 2 and 2. So, and this see here for this interval, so our given interval is here, the function is defined for this only, so we'll be taking first as this and then this is the second interval, third one is this. So when we can write here x belongs to minus 3 to minus 2, so what will happen here, so if we take here minus 3, so x equals minus 3, y dash will be simply 3, minus 3 minus 3 minus 5, and then minus 3 and plus minus 1. So it gives here y dash will be simply positive. So it is increasing in the interval minus 3 to 2. Okay, so let's move to second one. So if you want to check for if x belongs to minus 2 and 2, we can take here 0. So this is 0 minus 2 minus 2, y dash will be simply here, this is negative, this is positive, so this is negative, again here less than 0, so it is decreasing in the interval minus 2 to 2. Okay, so for last one interval, we can check here, it is here for x belongs to 2 to 5. If we take here 2 to 5, close at 5, if we take here more than 2, so it is here 3, positive, so y dash will be positive, so it is increasing, we can write here increasing in interval 2 closed at 5. Hope you enjoyed this, hope you like this video. If you like this video, if you think it must be shared among your friends, so don't hesitate to share, don't hesitate to like and subscribe my channel. Also do comment so that I can upload many more videos in coming days, and that will encourage me also. Thank you so much. God bless you.
Thank you so much for watching my video. I hope you like this video. Please do share this video with your friends, in your circle, in your social media, and please don't forget to subscribe my channel. Thank you so much. God bless you.